the last lecture we had discussed about two new operations, that is post increment and pre increment. Here you can see that we are calling them as prefix operation because the operator is before the operand. Here you can see also the operator is before the operand. And what is the operator? Operator is incrementation, but that is being denoted as plus plus, twice the addition operation or twice the subtraction operation. And in this, here we are talking of we are calling it to be postfix operation. Here you can see that the operand is coming first and the operators are following, right. So, the operators are following that. So, that is why this is known as postfix. Here also you can see the operand to be I followed by the operator minus minus, right. So, that is why these are called postfix or prefix. The significance of this, as we discussed in the last class, is that a particular variable will be first incremented here. In this case, it will be first incremented and then used in the operation. Here it will be first decremented, then will be used in the operation. While here it will be first the operation will be done and then the decrementation will be done. Here first the operation will be done, then the incrementation will be done. So, we can so that is what we have written here, first increment or decrement and then use it in the evaluation, and here increment or decrement is done after being used in evaluation. So, it will be clearer when we come with some examples. Here was the example that we had shown in the last class. T and M are two variables, M is initialized to 1, and when I am saying plus plus M, that means first I increment M. So, M will be, here you can see, as soon as I do that, M will become 2 and then that is being assigned to T. So, T becomes 2, whereas here you can see that M is 1 and we have done post increment. So, first the assignment operation will be done, that means M was 1. So, sorry, M was 2 here after this I am doing this. So, M will be so T will be 1. So, what will happen is M is 1. So, that M will be assigned to T. So, T becomes 1 and after that M will be incremented. So, ultimately M will be 2, but T will be 1. So, if you look at these two, you will find the difference between these. Okay. Let us have a few more examples. Suppose we have got two variables A and B whose initial values are 10 and 20. They are initialized to 10 and 20. Okay. Next, we carry out, look at this operation very carefully. It looks a little clumsy. Here there are two operators. One is this one, another one is this one. So, this is pre increment. So, this is equivalent to x is assigned 50 plus, as if I have put a parenthesis, but that is not required, that first A will be incremented and then that will be added to 50. So, what result do we expect? A was 10, A was 10. So, first that will be incremented. So, that will be 11 and that will be added to 50 and so x will get the value 61. All right. That is what will happen in this case. Okay. So, A is 11 and x is 61 as we have shown. Now, let us take this again. This is post increment. So, what do we expect here? Let us see what will happen in this case. First, Here after the operation is done, then A will be incremented. So, what will happen? X was 50, sorry, I am sorry, A was 10 and I am adding 50 and 10 and A, that means 50 plus 10, so that becomes 60, and that 60 is being assigned to X because the assignment operation is taking precedence over this post increment. So, we get X to be 60, but I have, my job is not yet clear because after A's participation in this operation, it will be incremented by 1. So, A was 10, then A will be made incremented by 1. So, it will become 11. So, consequently, this is the result what we will get. Okay. Now, let us see again here. What do you expect to happen? A is 10 as usual. A is 10 and B is 20. What is being said here? A is post increment, but B is pre increment, pre decrement. So, first B will be decremented. So, B will become 19. Decrement means by 1. So, it will be decremented, it will be 19. It will be added to A. What was A? 10. So, these two will be added, and what is that? 29, and that 29 will go to X. So, X will be 29, and then my job is not yet clear, not yet over. So, this will be incremented and A will be 11. All right. So, this is how the thing will happen. So, the result that we get in this case will be B will be 19 because B has been decremented, X will be 29 and A will be 11. I hope you have understood the flow. Okay. So, now this is another one. Here we really do not know what to do, because here I am incrementing, pre incrementing A, post incrementing A here. Now, I will take this value of A. Now, what will happen? Suppose the problem here is suppose A is, okay, let us take the case here A to be 10. Now, first I will decrement A, I will increment A. So, A will be 11, but A was, this A is not incremented. So, A minus 11. So, 11 minus 11, will it be 0? And then this will be A will be 12, or which one will be done first? This is a particular scenario for the same variable. If the post increment or post decrement are given, often that is implementation dependent and the compiler does not take it well. So, it often results in undefined value. So, you should try to avoid this as much as possible. You should not use this. You should use, you can use this pre increment, post increment. But as I said in the last class, I would strongly suggest that at the initial phase of programming, you avoid using this pre increment, post increment operations. Instead, although it will be a little laborious, you write x assigned x plus 1 or x assigned x minus 1 for pre increment and pre decrement. But it is good to know that C allows us with these facilities. Now, here is another one which at the initial phase you should not try to use unless you are very confident. We know if condition, then we do something, else something. So, there are three things. if some condition, then, although we do not write the then we do some operations, else we do some other operation. Now, the same thing can be written, so we call it a ternary conditional operation. Here we write it in a different way just to save space or now size, I mean the size of the program. What we do here, say grade greater than equal to 60, printf passed, otherwise printf failed. So, this means here this part is the condition part, and this part is the part that will be computed if the condition is true, and this part will be computed if the condition is false. All right. So, this is equivalent to writing if grade greater than equal to 60, printf passed, else printf failed. All right. This is equivalent to that. So, what is happening here in this example? So, the general syntax is, if there is an expression, there is a condition expression, then we carry out, if that is true, then we carry out expression 2. Otherwise, if it is false, then we carry out, if it is true, then we carry out this part that is following interrogation mark, and we carry out expression 3, that is the expression that is following the colon mark for the else case, or if the condition is false. So, this is again writing that if then else in a cryptic shorter way. This is known as ternary conditional operator, but again I would say that this is a specialty of C. It is good to know that, but at the initial phase of programming, I discourage you to use this. So, here is an example. What will this be? Can anyone tell me? We are computing the interest on the amount of money you have got in bank. This means here, let us look at this part. This is a ternary operator. If the balance is greater than 5,000, then you compute balance times 0.2, that means 20% of the balance, or compute 10% of the balance. If somebody has got a balance 6,000, then have 20% of that computed and assign it to the interest part. So, you see a bigger statement, if balance is greater than 500, then interest equals balance multiplied by 0.02, else interest equal to balance multiplied by 0.01. All these things can be done in one single sentence or one single statement using C. All right. So, that is why some people prefer to use such ternary operators, and you will also certainly use it, but when you are very confident about your programming. So, this now we come to a new construct, that is the switch construct. Now, in order to understand this, let us quickly go to the flow chart for a while. Say I draw a flow chart like this. I am evaluating some value here, all right, or maybe okay. I get some value from the user here. Okay, I read some value. Let me make it clearer. I read some value from the user. All right, something, read color. Now, here, depending on the color that the user supplies, earlier in this decision box, what were you doing? We were either going for true or for false. Now, here what we are saying, if the color is red, then we do something. If the color is blue, we do something. If the color is magenta, we do something. If the color is orange, then we do something. If the color is violet, we do something. Okay? So, the same diagram I can draw in a different way, that is, I am reading color, and then as if I am coming to a switch box. Think of this to be a switch box where number of switches are there, all right, and number of switches are there. Now, depending on what value of the color is coming, so this may be the red switch, this may be the blue switch, this may be the orange switch. Depending on which switch, which value is coming, so let the value be V. If V is R, then this switch gets closed and we follow this path. If the V is blue, then this switch gets closed and we follow this path. If V is orange, then this switch gets closed and we follow this path. All right. That is why, because of this analogy with switch, this statement is also known as switch statement. This is also very much used for branching. Branching we have seen with if else type of thing, and here also we will see another variety of a C construct called switch, using which we will do that. Okay. So, let us see here. Now, let us look at the construct of this. The syntax of the switch statement is this: switch expression, then case expression 1, expression 2. Let me give an example first, then it will be better. Okay, I will come back to this. So, here is the total switch structure. It is a multiple selection structure. So, I come to this point, switch, if the case is A, if it is the case that the color is red, like that, if the case is A, then I take the case A actions and then come out. Otherwise, I take the case B actions. If the case be B, then only I will take the case B action and then come out. Similarly, if there may be different cases. So, what we are getting here is an example that we are showing here. What we are getting here is, using this case construct, multiple branching we are accommodating in one shot. Let us look at this. I was giving an example with color. Here it is an example with a letter. So, I have read some letter from the user. Okay, some letter has been, now that letter can be anything, A to Z, say A to Z. So, if the case is that the letter is A, look at how it has been written, case A. Before that, switch, what is my variable on which I am switching? Switch on variable letter. In the earlier example, it was switch on the variable color. So here we start with switch on the variable letter, and what are the possible switches? I encapsulate that in two braces, just as we do. Now within this I am taking multiple decisions, multiple possibilities are there. For example, if the letter is A, that means if it is a case that the letter is A, then we put a semicolon. Then I write down print the first letter. So what will be printed? First letter. And then there is a break statement. What this break statement does? That you execute this and then you come out of this entire switch box, come out here. It means join the next statement. If the letter was B, then here it is not written, I am writing case B. Printf second letter \n, and then break. That means if the case is B, then I will print this, and after that with the break I will come out of this. Now after that I have not written anything else, but I have written case Z, only this case Z. All right. Printf last letter as is shown here, and then break. Now if somebody, this letter was P, if this letter was Q or some other alphabet, sorry, I mean anything, small alphabet or capital alphabet, X, whatever, in that case what do I do? This one only tells me what I can do if the letter is A, or if the letter is Z, or in my case if the letter is B. But if it be something else otherwise, then we use this statement called the default statement. If anything is other than what has been specified here, then we will say that it is some other letter, and then break. You see here, if the letter is A, then only I entered here and then went out. If the letter is B, then I only entered here. If the letter is C, then I will come to default. If the letter is C, it is not specified here, I will come here and I will escape. I will write it is an intermediate letter and then come out. Okay. So with this understanding, if we can go back to the earlier slide, the flow chart, then we can see that the flow chart will be something like this. We start, then we evaluate expression, then we come here, it is equivalent to case A, yes, do something, and then break. Otherwise, it will come here, is looking at K, I am just doing this, case Z, if true, then do something and then break, right. Otherwise, so this is true, this is false, this is true, this is false. Otherwise, default, I will come here, do something and then break. Now all these breaks brings me to the next statement after the case statement. So anything that is here, whenever I encounter a break, this brings me here, this also brings me here, this also brings me here, and I continue following the sequential nature of program from here. All right. So we have seen. So here is another nice example. You can look at it. Say here switch. I am switching on an expression. What is that? Choice to upper. Now this has got some multiple parameters into this. Let me take it up in the next lecture so that I can devote some time on this. Thank you.